In continuation of our previous video on a few examples on impulse and momentum, we're going to look at another example in this exercise where we have an unknown force which accelerates an 8 kilogram block from rest, which means it's not moving in the beginning, to 15 meters per second in 4 seconds. We want to calculate the change in momentum of the block and the magnitude, the size, of the average force acting on the block. Let's see if we can draw something to help us understand what's happening. So we have this block of mass m, which is not moving, okay, because it's at rest. And then the same object, we have a force F average applied on this side, and this one will accelerate our block and it will acquire a velocity of 15 meters per second, if I remember correctly. 15, yes. And the time difference here is 4 seconds. We also know that the mass of our object is 8 kilograms. For question A, the change in momentum. Question A, the delta P. That's what we want to calculate. Now we know that delta P is going to be m times delta V. We also know that the mass, we can rewrite delta V as V final minus V initial. And let me proceed with some number substitutions. The m is 8 kilograms. The final velocity is going to be 15 minus 0. And this will give us a change in momentum of 120 kilograms meters per second, and that's the change in momentum. So the object is being accelerated to the right. Question B, the magnitude of the average force acting on the block. For B, we want to calculate the F average. Now for this one, we have two ways to do it. Okay, so let's see the first approach. For the first approach, we're gonna use the scenario that tells us that the change in momentum is equal to the impulse, which is given by the product of the force times the time that the force is acting on the object. So if we substitute the numbers, we're gonna have a change in momentum of 120 being equal to the F average that we don't know, and this force acted for 4 seconds on the object. So if we solve this one for F average, we're gonna have 120 divided by 4. So the force is going to be 30 newtons. Now, the second approach, which is not much different, it's basically the same basis, is going to use the Newton's second law of motion, which will be given like this. So the force acting on the object, the resultant force, is going to be the change in the rate of change in momentum. So delta P over delta T, and delta P you calculated before as 120 over 4 seconds, and basically you see that we have the exact same number coming from the exact same calculation. That's not random, of course. So this is an example with two different approaches. Is there another question? No. Let's look at problem 3, which looks a bit longer. A 350-gram ball is traveling west at 25 meters per second when it is struck horizontally by a baseball bat, causing it to travel east on the opposite direction at 50 meters per second. If the bat was in contact with the ball for 25 milliseconds, what average force did the bat exert on the ball? B. Calculate the impulse exerted on the ball. C. What is the change in momentum of the ball? Okay, so looks quite long, and let's write down all the information we have. We have a mass of 350 grams, which I will immediately convert into kilograms, and I can leave it like 335 times 10 to the minus 2 kilograms. We have the let's try and draw this scenario. We have this baseball bat looking like this, and we have the ball that is traveling in this direction with 25 meters per second. Okay, and then once the impact happens with the bat, what we have after is that the ball is going to move in this direction with 50 meters per second, if I remember correctly the numbers. Yes, west and east. And this contact, this delta T, was 25 milliseconds. In other words, 25 times 10 to the minus 3 seconds. So the ball is coming in this direction, in the west direction with 25 meters per second. The bat hits the ball and then it leaves on the other direction with 50 meters per second. Now the first question is, what is the average force that the bat exerted on the ball? For A. So the average force, we can say that is going to be the change in momentum over the change in time. Now, the change in momentum on the ball, what is the average force? Yes, so the change in momentum on the ball. Again, this one you can approach it from this formula, or you can also say that the change in momentum is going to be equal to the impulse, which is going to be the F times delta T. It's exactly the same as the previous example. Whichever approach you decide to take, you need to do similar calculations. It's just a different way of going into the same result. So we are interested in this variable here, okay, or this one, and in both scenarios we need to get the change in momentum, and we already have the change in time. So let's try and calculate the change in momentum of the ball. So the change in momentum is going to be its mass times the change in velocity. This is where we need to be very, very careful. Now, the change in velocity is written as v final minus v initial. The mass is 35 times 10 to the minus 2. The final velocity is going to be 50 meters per second minus the initial velocity. What's this? The initial velocity is pointing in the east direction, so this is the negative direction. So this is going to be minus the 25. This is very, very important for your calculations. And if we do not make the mistake at this point here, then we'll hopefully end up with the right result. So this is 50 minus 25. It's going to be 50 plus 25, that's 75, and 35 times 75 is going to be 2,625 times 10 to the minus 2 kilograms meters per second, and that's the change in momentum for A. Now we can divide this one. So the average force is going to be the change in momentum over change in time, and 2,625 times 10 to the minus 2. The change in time, we said it's 25, 10 to the minus 3, and this one should give an example, a number of 105 times 10, so this is 1050 newtons if my calculations are correct. You can double check and let me know in the comments if that's the right answer. Now that's for A. This is a quite long exercise. Question B, calculate the impulse exerted on the ball. So we've done most of our calculations, right? So the impulse is going to be equal to the change in momentum, which is basically what we have over there. It's 25 times 10 to the minus 2 newtons times seconds, because, or kilograms meters per second, it's the same, it's equivalent units. So we calculated B already from our calculations for A. Now C is asking for the change in momentum of the ball. What is the change in momentum of the ball? So the change in momentum, the delta P, is going to be equal to the number that we calculated before. So in other words, 26 times 10 to the minus 2 newtons per second. So question A was asking for the average force applied on the ball. Question B, the impulse, which is the change in momentum, and question C, it's the change in momentum of the ball. So you can see that whenever we get a question about the impulse or the change in momentum, it's basically the same thing. So you don't need to calculate anything new. The only thing that you can pay attention to is the units. The units are quite the same. Maybe you can say whenever you express change in momentum, you can express that into kilograms times meters per second, and whenever you have impulse, newtons times second, but both units are equivalent. I hope this was helpful. Let me know in the comments if you end up with the same calculation.